The purpose of the bleed air system is to collect and distribute bleed air to the systems that use bleed air. The bleed air system gets bleed air from three sources: the engines, the APU, and an external air cart. The components and the systems that use bleed air are the engine starter, the air conditioning packs and pressurization system, wing and engine thermal anti-icing, pressurization for the potable water tank, and pressurization for the hydraulic reservoirs. The bleed air system has two sides, left and right. The isolation valve separates the left side and the right side of the bleed air system. The engine and APU bleed air valves control air that goes to the bleed air system. The air conditioning pack valves control air that goes to the air conditioning packs from the bleed air system. The controls and indicators for the bleed air system are on the forward overhead panel. The isolation valve switch controls the isolation valve. The engine and APU bleed air switches control the engine and APU bleed air valves. The air conditioning pack switches control the air conditioning pack valves. The bleed air duct pressure indicator shows the bleed air pressures for the left and right ducts. The APU is a primary source of bleed air for air conditioning and engine starts during ground operations. The APU bleed valve controls the APU bleed air that goes to the left side of the bleed air system. Open the APU bleed air valve and look at the indications. When the APU is on and the bleed air valve is open, bleed air from the APU goes to the bleed air system and the duct pressure increases. Bleed air is now available for air conditioning and engine starting. Now select the left air conditioning pack valve to auto and look at the indications. Before you select the right pack to auto, select the isolation valve to open. Now, select the right pack to auto. The APU now supplies bleed air to the bleed air system and the air conditioning packs. During flight or on the ground, the engines can supply the bleed air system with bleed air. The engine's compressors supply bleed air to the bleed air system. The engine bleed air valve controls the bleed air that enters the bleed air system. If the switch for the engine bleed is open, the engine bleed air pressure opens the valve. The engine bleed air switches are normally kept in the on position. When the engines are running, the bleed air valves open and engine bleed air enters the bleed air system. When the engines supply bleed air, select the air conditioning packs to auto. When the left engine valve switch is on and the APU bleed valve is open, the dual bleed light illuminates. The dual bleed light shows that it is possible to back pressure the APU with engine bleed air. The dual bleed light illuminates if the bleed valve switch for the right engine is on, while the isolation valve and APU bleed valves are open. In this example, the dual bleed light shows that the right engine bleed air can also back pressure the APU. While the dual bleed light is illuminated, avoid engine power above idle. Now that the engines supply bleed air, the APU bleed air is not necessary. Close the APU bleed air valve and look at the indications. The isolation valve separates the left and the right sides of the bleed air system. The isolation valve switch has three positions: closed, auto, and open. When the switch is in the open position, the valve is always open and the left and right sides of the bleed air system are connected. Now close the isolation valve. When the switch is in the closed position, the isolation valve is always closed and the left and right sides of the bleed air system are separated or isolated. Now select Auto on the isolation valve switch. The normal position of the isolation valve switch is auto. When the switch is auto, the isolation valve can be open or closed. When the pack switches are auto or high and the engine bleed air switches are on, the isolation valve is closed. But if a pack switch or engine bleed switch is selected to off, the isolation valve opens. Move the number 2 engine switch to off and look at the isolation valve. With the isolation valve switch in auto, the isolation valve opens when the number 2 engine switch is moved to off. Now move any bleed air switches, the pack valve switches, or the isolation valve switch and look at the position of the isolation valve and other indications. Press the green arrow when you are finished. While parked, you may use an external air cart to supply an alternate source of air. The external air cart connects to the right side of the airplane and the bleed air system. Before using the external air cart, make sure the battery switch is on. The battery powers the protective circuits of the bleed air system. Turn on the battery now. With the temperature controls set as desired, select the recirculation fan to auto. Continue. Now, open the isolation valve. Because the external air cart supplies the air for the bleed air system, the APU bleed is not necessary. Turn off the APU bleed. When an external air cart supplies air, you can select the packs to auto or high. Turn both packs to auto now. Continue. Review the steps necessary to connect an external air cart to the bleed air system. Press the green arrow to continue. When the external air cart supplies air, the bleed air duct pressure should be between 20 psi and 25 psi. If the bleed air duct pressure is less than 20 psi when an external air cart supplies air, use the APU if it is available. To start, select the isolation valve to auto. Now, turn on the APU bleed. The APU supplies air to the left pack, and the external air cart supplies air to the right pack. Review all the steps to connect an external air cart to the bleed air system. Press the green arrow to continue. After parking at the terminal, you change the source of bleed air for the bleed air system from the engines to the APU. Before you open the APU bleed valve, open the isolation valve. Now, open the APU bleed valve. Now, shut down the engines by touching the start levers on the aisle stand. The APU now supplies bleed air for the packs. To shut down the air conditioning system, turn the packs off. To fully shut down the bleed air system, turn off the APU. The APU bleed air valve closes when the APU is shut down. The bleed air system is now shut down. Let's look at the steps necessary to perform a no-engine bleed takeoff and landing. If additional thrust for takeoff is necessary, perform a no-engine bleed takeoff. The APU is necessary for a no-engine bleed takeoff and landing. If additional thrust is necessary for a go-around, perform a no-engine bleed landing. The steps for a no-engine bleed landing are the same as a no-engine bleed takeoff, but you do the steps during descent when below 10,000 feet. Just before takeoff, or when below 10,000 feet, you set the switches for no engine bleed with a letter C pattern on the air conditioning bleed air controls panel. To start, make sure the right pack is in auto. Now close the isolation valve. Make sure the left air conditioning pack is in auto. Turn off the number 1 engine bleed. Turn on the APU bleed. Last, turn off the number 2 engine bleed. This sequence of steps has turned off the bleeds from each engine, while the flow of bleed air continued to at least one pack. The bleed air system is now set for a no-engine bleed takeoff or landing. Review the steps, then press the green arrow to continue. After you complete a no-engine bleed takeoff, do the steps in the opposite order to put the bleed air system in the normal configuration for flight. Turn on the number 2 engine bleed. Turn off the APU bleed. Now, before you turn on the number 1 engine bleed, make sure that the cabin rate of climb is stable. This makes sure the APU bleed valve is fully closed before you open the engine bleed valve. Turn on the number 1 engine bleed. Make sure the left pack is in auto. Turn the isolation valve switch to auto. Then, make sure the right pack switch is in auto. The sequence of steps sets the bleed air system for normal flight, while the flow of bleed air to at least one pack continued. Review the steps, then press the green arrow to continue. The overheat test switch tests the detector circuits of the wing body overheat system. To do the wing body overheat test, press the overheat test switch for a minimum of 5 seconds. Press the overheat test switch now. The wing body overheat lights, the master caution lights, and the air conditioning system annunciator light illuminate after you hold the switch for 5 seconds. When you release the switch, the lights extinguish if the system is correct. Let's discuss some of the non-normal indications on the air conditioning bleed air controls panel. When the temperature of the bleed air is more than limits, or when the pressure of the engine bleed air is more than limits, the master caution and air conditioning annunciator lights illuminate, and the bleed trip-off light illuminates. When the bleed trip-off light illuminates, the related engine bleed air valve closes. After the bleed air is cool, press the trip reset switch. When you press the trip reset switch, the bleed trip-off light extinguishes and the related bleed valve opens. If the temperature and pressure are now less than limits, the system operates normally. If the temperature or pressure are still greater than limits, the bleed trip-off light illuminates again and the related bleed air valve closes. If the bleed trip-off light remains illuminated and wing anti-ice is necessary for the flight, turn off the pack on the affected side. In this example, turn off the right pack. When you turn off the pack, the isolation valve opens and the bleed air system supplies air to the right side for wing anti-ice. There are 2 wing body overheat lights on the air conditioning bleed air controls panel. The lights show that there is a duct leak in the bleed air system. The wing body overheat detection system has sensors that detect bleed air duct leaks from the bleed air system. The system monitors ducts in the wing and engine strut areas, the air conditioning bays, and the bleed duct from the APU. When the left wing body overheat light illuminates, the system has found a leak in the left side of the bleed air system, which includes the duct from the APU. Reset the master caution system. When the right wing body overheat light illuminates, the system has detected a leak in the right side of the bleed air system. Reset the master caution system. The purpose of the air conditioning system is to decrease the temperature of the bleed air and to distribute the air to the cockpit and cabin. The system has two packs that are the primary source of conditioned air and pressurization for the cockpit and passenger cabin. The two packs are the same, and one pack can supply a sufficient quantity of conditioned air and pressure for all operations. The controls and indications for the air conditioning packs are on the forward overhead panel on the air conditioning bleed air controls panel, and the cabin temperature controls panel. The packs decrease the temperature of the warm air from the bleed air system with a sequence of heat exchangers and an air cycle machine. The heat exchangers use external airflow to decrease the temperature of the warm bleed air. The ram air doors control the flow of external air to the heat exchangers. The ram air doors are fully open while on the ground and during slow flight with the flaps extended, and move as necessary between full open and full closed in cruise flight. When the ram air door is full open, the related ram door full open light illuminates on the air conditioning bleed air controls panel. The pack temperature control valve controls the quantity of warm air that is mixed with the cool air downstream of the air cycle machine. With the pack temperature control valve, the pack supplies air at the temperature of the zone with the lowest set temperature. If the main controller or valve fails, the opposite pack controller uses the standby pack temperature controller. Before the pack, some of the bleed air is sent to the trim air system to control the temperature of the cabin zones. The trim air system is discussed in another lesson. To control the bleed air that goes into the pack, you use the air conditioning pack switches on the air conditioning bleed air controls panel. The air conditioning pack switch controls the related pack valve. Turn off the pack. When you set the pack switch to off, the pack valve closes fully and bleed air does not go into the air conditioning pack. Set the pack switch to high. When you set the pack switch to high, the packs supply the maximum airflow. Now, set the pack switch to auto. When you set the pack switch to auto, the pack adjusts to the high flow or low flow to keep sufficient pressurization and conditioned air in the cabin. Downstream of the pack, the air conditioning system supplies the cool air to the flight deck and the passenger cabin. The air from the left pack first goes to the flight deck, and the rest goes to the mixed manifold. The air from the right pack goes to the mixed manifold. From the mixed manifold, the air goes to the forward passenger cabin and the aft passenger cabin. Recirculation fans collect air from the forward cargo bay and sends it to the mixed manifold. The recirculation fans decrease the bleed load on the engines and save fuel. You can control the temperature in 3 zones: the flight deck, the forward passenger cabin, and the aft passenger cabin. The 2 packs supply air at the temperature of the coldest requested temperature of the 3 zones. The trim air system uses warm bleed air from upstream of the air conditioning pack to warm the pack air to the necessary temperature for the related zones. The trim air switch controls the trim air regulator and shutoff valve. The trim air pressure regulator and shutoff valve controls the air that goes to the trim air system. There are 3 trim air modulating valves. The 2 pack controllers use the valves to control the temperature in the zones. The right pack controller is the primary controller for the flight deck trim air valve, and the left pack controller is the secondary controller. The passenger zone trim air valves have 1 controller. The left pack controller operates the aft cabin zone valve, and the right pack operates the forward cabin zone trim air valve. The left and right pack controllers also control the temperature control valves in the packs. Because the packs supply air at the temperature of the coldest zone, that zone does not need trim air and the related trim air valve is closed. The controllers use trim air modulating valves to increase the temperature in the other zones to the necessary temperature. Now, select a warmer temperature in the aft cabin. The aft cabin temperature trim air valve opens to allow warm air to the aft cabin. Because the forward cabin is the coldest zone, the related trim air modulating valve closes and packs supply air at the requested temperature of the forward cabin. The equipment cooling system keeps the temperature of the cockpit instruments and the electronic equipment in the E&E bay at less than the operating limits. The system has a normal supply fan and a normal exhaust fan. Also, there is an alternate supply fan and there is an alternate exhaust fan. The supply fan collects cool air from the passenger cabin and supplies it to the cockpit displays and electronic equipment in the E&E bay. The exhaust fan collects warm air from the cockpit displays, the circuit breaker panels, and the electronic equipment in the E&E bay. On the ground and in flight, with a low differential pressure, the overboard exhaust valve is open and the system discards the warm air overboard. In flight, at a higher differential pressure, the overboard exhaust valve normally closes and the system supplies the warm air to the lining of the forward cargo bay. The controls for the equipment cooling system are on the forward overhead panel. The supply switch operates the normal or alternate supply fan. The exhaust switch operates the normal or alternate exhaust fan. There are low airflow detectors in both the supply duct and exhaust duct. If the selected fan does not operate and the airflow stops, the related off light illuminates. When the off light illuminates, you select the related alternate fan. Select the alternate exhaust fan now. The off light extinguishes after the air starts to flow again. The alternate fan supplies the same quantity of airflow as the normal fan. We will now look at some non-normal conditions related to the air conditioning system. If the temperature in the supply ducts to the cockpit or passenger cabins is more than limits, the related zone temperature light illuminates on the cabin temperature controls panel. When the zone temperature light illuminates, the related trim air modulating valve closes. Push the master caution light to reset the warning system. To decrease the temperature in the related trim air supply duct, select a colder temperature with the related temperature selector. To let the trim air modulating valve operate as usual and to extinguish the zone temperature light, push the trip reset switch on the air conditioning bleed air controls panel. Now, with the air temperature selector, select the aft cabin to see the aft duct temperature. If this temperature in the duct increases quickly, then select the trim air switch off. When the trim air switch is off, the trim air valve closes. The packs operate independently. The left pack supplies air at the temperature selected by the flight deck temperature control selector, and the right pack supplies air at the average temperature of the forward and aft passenger cabin temperature selectors. The zone temperature light also illuminates if there are failures in the pack controllers. If the primary and secondary flight deck controller do not operate, the flight deck zone temperature light illuminates and the packs operate independently. If a flight deck temperature controller, the forward passenger cabin controller, or the aft temperature controllers fail, then the related zone temperature light illuminates when recall is selected. Select Recall now. In this case, the packs also operate independently. Clear the master caution. If the temperature in the pack is too high, or if the pack output temperature is high, then the pack light illuminates and the related pack valve closes. Reset the master caution system. To decrease the load on the pack, select all the temperature selectors to a warmer temperature. Continue. Continue. To let the pack operate normally, push the trip reset switch on the air conditioning bleed air controls panel. The pack light will also illuminate if both the primary and secondary controller for the related pack do not operate. In this case, all control of the pack is lost and the system will not reset. If the primary or standby controller for the related pack do not operate, the pack light illuminates when recall is pressed. Control of the pack changes to the standby controller if the primary controller does not operate. The pressurization system of the 737 Next Generation airplane is similar to the pressurization systems of other Boeing airplanes. The air conditioning packs supply pressurization for the cabin. The pressurization system has an outflow valve on the aft fuselage. The system also has two digital cabin pressure controllers in the forward equipment and electronics or E&E bay. The pressure controllers use the outflow valve to control the cabin altitude. One controller operates the pressurization system and the other controller is a backup. The pressurization system also has safety components to keep the cabin pressure in limits. There are two safety relief valves for positive pressure and one negative pressure relief valve. If the differential pressure is greater than allowed, the safety relief valve opens to decrease the pressure in the cabin. The negative pressure relief valve opens when the external pressure is more than the cabin pressure. There are no cockpit indications when any of the safety relief valves operate. The controls and indicators for the pressurization system are on the forward overhead panel. You set the flight altitude of the planned flight with the flight altitude selector on the cabin pressure control panel. Set a cruise altitude of 39,000 feet. You set the elevation of the destination airport with the landing altitude selector. Set a destination elevation of 2,700 feet. You select the mode of the pressurization system with the pressurization mode selector. The selector has three positions: auto, alternate, and manual. The outflow valve position indicator shows the position of the outflow valve for all modes of the pressure controllers. The toggle switch controls the outflow valve when the pressure controllers are in manual mode. The switch is spring-loaded to the center position. Select Auto now. There are two indicators for the pressurization system on the cabin altitude panel. The cabin altitude differential pressure indicator shows the altitude of the cabin and the pressure differential. And the cabin rate of climb indicator shows the rate of climb of the cabin. The altitude horn cutout switch stops the cabin altitude warning horn. There are 4 lighted indicators that show the status of the pressurization system. To see how the pressurization system operates during a normal flight, you will now plan and complete a flight from home airport to vacation airport. During the pre-flight, you set the flight altitude on the cabin pressure control panel. Set the planned flight altitude from the dispatch sheet. Next, set the elevation for vacation airport. Last, make sure the pressurization mode is in auto and the auto fail light is extinguished. The pressurization system is now set for flight. You will now see how the pressure controller operates during a normal flight profile. While parked on the ground and during taxi with low engine thrust, the pressure controller fully opens the outflow valve to depressurize the airplane. During the takeoff roll, the pressure controller starts to close the outflow valve. The cabin pressurizes to an altitude of 200 feet below the airport elevation. The decrease in cabin altitude improves system performance and increases the comfort of the passengers during takeoff. While in flight, the pressure controller uses the outflow valve to control the cabin altitude. During climb, it keeps the cabin altitude proportional to the airplane altitude. When the airplane is at the planned cruise altitude, the pressure controller starts cruise mode. Although the airplane altitude may change a small amount, the cabin altitude remains constant during cruise. But if the differential pressure is at the maximum, the cabin altitude changes to keep the differential pressure at the correct limit. When the airplane descends from cruise altitude, the pressure controller commands a proportional cabin altitude descent to 300 feet below the planned landing elevation. By landing with the airplane pressurized, cabin altitude changes are minimized during approach. After landing, the outflow valve opens slowly to depressurize the airplane. After flight, there is no flight crew action for the pressurization system. There are several non-normal operations for the pressurization system. We start with the off-schedule descent. The off-schedule descent light illuminates if the airplane begins to descend before it reaches the flight altitude set in the controller. For example, if a flight aborts during climb and returns to the takeoff airport, the off-schedule descent light illuminates when the airplane starts to descend. The pressure controller begins a cabin altitude descent to 300 feet below the departure airport elevation. If you start to climb again, the off-schedule descent light extinguishes and the pressurization system continues to operate as usual. If during flight it becomes necessary to divert to an alternate airport, you must set the landing altitude to the elevation of the new airport. Set the elevation of the alternate airport. When you start to descend, the pressure controller decreases the cabin altitude to 300 feet below the new landing altitude in proportion to the airplane descent. If the pressure controllers fail, lights illuminate to tell you of the failure. If the primary pressure controller fails, the auto fail and alternate lights illuminate. Also, the master caution light and the air conditioning annunciator light illuminate. Press the master caution light now to extinguish the warning lights. The green alternate light shows that the alternate pressure controller now controls the pressurization system. The auto fail light shows that the primary controller has failed. To extinguish the auto fail light, select alternate on the mode selector now. The alternate pressure controller operates the same as the primary pressure controller. If the two pressure controllers fail, the auto fail light illuminates and the master caution and air conditioning annunciator lights illuminate. Press the master caution light to extinguish the warning lights. If the two pressure controllers do not operate, you must manually control the pressurization system. Select Manual on the mode selector now. When you select the manual mode, the manual light illuminates. To start, use the placard below the pressurization panel to find the correct cabin altitude for the current flight altitude. If your cruise altitude is 39,000 feet, read the correct cabin altitude of 8,000 feet. The outflow valve switch controls the outflow valve. You toggle the switch until the cabin altitude is at the value you read on the placard. In this example, the cabin altitude is above the necessary altitude. To decrease the cabin altitude, toggle the outflow valve to close. Since the pressure controllers do not operate, you must use the outflow valve switch to manually control the cabin altitude until landing. If the cabin altitude is greater than 10,000 feet, the cabin altitude warning horn operates. To stop the horn, press the altitude horn cutout switch.